Hi, I am Ahmad Mahidul Kohar from Universitas Negeri Surabaya. Thank you. In this occasion, I would like to share my paper with the title Prospective Teachers' Knowledge of Evaluating Student Errors on Area Conservation Task. So this research was motivated by the understanding on area conservation, which is challenging and problematic for students. Yeah. The term conservation of an area refers to the invariance of the quantitative value of the area of a geometrical shape, even though the shape is converted into different forms qualitatively. As you can see from these pictures, a tangram is an example of how conservation is used in the concept in mathematics. Student challenge, in understanding area conservation, students need to determine the area of a triangle, for example, even though they already understand conservation area on a parallelogram. Errors in determining the area of a rectangle when the tiles that make up the rectangular model are arranged in different ways, even though the number is fixed. The use of visual estimations that are not followed by formal visual reasoning, which makes it quite unreliable to justify the area of two triangles with different side lengths. And then research on pedagogical content knowledge of area conservation, which is now emerging in teacher education. Despite research on exploration of content and pedagogical knowledge of prospective teachers on geometry topics has been reported by previous researchers, there is still much that needs to be understood about the knowledge of prospective teachers on area measurement topics, especially those related to conservation areas. In content knowledge, this exploration can focus on the nature of the conservation area concept, as well as the consequences of relevant mathematical properties. In terms of pedagogical knowledge, this can focus on exploring the types of student strategies in completing conservation area-based tasks, and the possible errors or misconceptions associated with them. So as teacher and prospective teachers, they need to revisit the content knowledge on area conservation. As you can see from these pictures, how we need to formulate. We need to derive the formula of area of a triangle, for example. So as you can see that there are some strategies that we can use. One of them is student invented strategy, that is verifying the area formula for a triangle, as you can see from here. So that we can move some parts of a triangle into the other parts so that it can make a rectangle like this one. So by using the formula of rectangle, we can derive the area of the formula of area of triangle. And then the other one, we can use 1/2 a triangle to verify the formula. We can also use the use of obtuse triangle and half of the height to verify the formula. As you can see here. And then also we can use an obtuse triangle and half of the base to verify the formula. So those are things that we can use to revisit the content knowledge of area conservation regarding formula of triangle area. And then there are some frameworks to analyze features CK on content knowledge and PCK, pedagogical content knowledge on area conservation. Researchers investigated prospective teachers' content and pedagogical knowledge on geometry concepts through some analytical frameworks. Some, for example, scrutinize teacher responses on students. Work on similar triangle tasks by focusing on aspect of mathematical or instructional focus, pedagogical actions, form of address, degree of student error, and act of communication barrier. In this research, the authors applied the same framework used by Sun 2013 to investigate teacher evaluation on students' work on area conservation tasks. So that the aims of the study is to analyze prospective teachers' evaluation in the form of conjectures and responses on triangle area conservation tasks. Research method. To collect the data, we administered a questionnaire of area problem task, to a sample of 28 prospective teachers who were studying at an elementary education program in a university in Surabaya. And then we analyzed the prospective teacher responses on the questionnaire. So these are the instruments that we can use. In general, task one is task one asks the prospective teachers to give the opinion whether the statements of Zara is correct or not. With the statement is regarded with the mathematical statements regarding the area conservation area conservation task, with the same base and the same height of two triangle, and then whether the task two, the base and the height of each of triangles have different sizes, so which makes it different with the task one. Okay. So to analyze, we use analytical framework of data analysis. So to collect the participants' identification of student errors might occur when solving area conservation problems, we focus on some aspects. For example, whether the prospective teachers correctly determine that the Zara statements given as information of the problem is incorrect, and then what possible errors, what underlying mathematics the prospective teachers diagnosed as reasons that result in Zara's errors. And then also we collect the participants' responses on student errors in solving area conservation problems based on three concerns, which are mathematical focus, whether conceptual or procedural, and then pedagogical actions, whether it explains, props student thinking, or even suggests cognitive conflict, etc. And then we also consider on the form of address, which is whether it should tell on or give ask. So then results and discussion, for example. So first one, I would like to tell you about the identification of possible student errors on area conservation task. So as you can see, that this table indicates that most participants, most of the participant responses are regarded as correct answers, indicated by the response claiming that triangles with the same basis and the same altitudes have the same area, like this one. This can be seen, from some student teachers responses, Okay. And then about possible errors they identified from Zahra's statement, In this one, we can see that this table indicates that most participants tend to explain that errors might occur due to the use of irrelevant visual analysis. This can be seen from an example that describing possible errors caused by taking the visual information too much into account, so that no mathematical reasons are provided to explain the phenomena of beam lighting on the corridor, as we see in the task. Okay, then how about possible errors, possible underlying mathematics, diagnosed as reasons that results in Zahra's errors, Okay. This response, points out that the sources of mathematics underlying student errors can be explained through whether the students are able to use a more flexible strategy to find the area of triangle, instead of the only one single strategy, which the triangle area formula, Okay. Next, about pedagogical responses on possible student errors on area conservation tasks. So for the first aspect about response regarding mathematical focus, yeah, as you can see from this table that most prospective teachers agree with the idea of the use of conceptual understanding of area conservation for a triangle to help students reduce any errors, yeah, by focusing on the behavior of the base and the height of the triangle, yeah. That is whether they have the same measure or not, yeah. Okay. And then related to pedagogical actions, yeah. As you can see here, what is that? Participants tend to agree in these occasions that post-probing students, to think of idea of area conservation in improving their understanding of a triangle is suggested, yeah, for alternative pedagogical actions, yeah, as you can see here. Okay. And then report response to related to form of address, yeah. So from these tables, we can see also that most participants agree with the idea of give and ask, yeah, here of addressing idea of area conservation to students, yeah. However, yeah, for example, some participants also choose, yeah, to show that the situation and directly tell the students about the situation. Although prof students thinking, yeah, which is providing explanation that the two triangles have the same measure is suggested. Okay. Now about degree of student errors use, yeah. Okay. Regarding degree of student error use in this table, we can see that none of the participants suggest using student errors as a focus to improve student understanding on area conservation concept. Yeah, while the remaining participants give responses on intermediate or rare. Yeah, in this case. Okay, we come to the conclusion of the study. The results of the study indicate that prospective teachers are correct in identifying and interpreting the existence of a mathematical error from a triangle with the same height and base. However, some prospective teachers cannot fully evaluate how to apply the concept of conservation of area to triangles with different heights and bases. Yeah. And then the pedagogical responses indicate pedagogical action by re-explaining the main feature of the task solution instead of using student errors as a tool to probe students' thinking. So this is the end. These are my references, yeah. And then thank you for your attentions, yeah.